Hi everyone, welcome to MyMax Academy. In this video, we'll continue with the chapter Coordinate Geometry, which is your chapter 7 from your 10th standard CBSE Mathematics. I'll continue with exercise 7.1 in page number 161 of your textbook, problem number 7. Problem number 7, which is, it says, find the point on the x-axis which is equidistant from the point 2, minus 5 and minus 2, 9. So, which means there is a point P and this point is on the x-axis. So, which means that point will be of the form x, 0, because since the point lies on the x-axis, the y coordinate of the point will be 0. Any point on the x-axis, its y coordinate is 0. So, any point on the x-axis will be of the form x, 0. Any number, 0, that x we have to find, says that this point is equidistant from two other points. So there is one point here. Suppose you call this as A. That is given point is 2, minus 5. 2, minus 5. This distance is same as another point B, which is minus 2, 9. So we have to find the point P such that this point is equidistant from A and B, which means PA equal to PB. The distance between A and P is same as distance between B and P. And this point lies on the x-axis. That's why we have taken this, the coordinate of the point as x, 0. So any point on the x-axis, it will be x, 0. Any point on the x-axis, it will be of the form x, 0. Because any point on the x-axis, its y coordinate will be always 0. That's why we call y equal to 0 as equation of x-axis. Y equal to 0 becomes the equation of x-axis because any point on x-axis, its y coordinate is 0. So any general point if I want to take, it is x, 0. Now here we should find what is that x such that the distance between A and P is same as distance between B and P. So we'll say let P of x, 0 be a point on the x-axis which is equidistant from point A of 2, minus 5 and B of minus 2, 9. Minus 2, 9. Now we should find that point P, which is equidistant from A and B. So which means, so what is given is AP is equal to BP. That is given. The distance between A and P is same as distance between B and P. What is this point? So to find this point, we should find x. Now AP is equal to BP. So which means what is the distance between A and P? So we'll take, suppose we'll take this as x1, y1 and this as x2, y2. Let's find the distance between A and P. That is AP. So AP is what? Square root of distance between these two. That is x2 minus x1. x2 is x minus x1 is 2, the whole square, plus y2 is 0 minus y1 is minus 5, the whole square. Right? This is minus 5. So y2 minus y1, the whole square, that is same as equal to BP. Distance between B and P is, we'll take this as x1, y1 and this as x2, y2. We are finding the distance between this B and P. Right? So that will become again x2 minus x1, the whole square, which means x minus of minus 2, that is x2 minus x1, the whole square, plus y2 minus y1, the whole square. Right? Now we need to remove the square root. So we will squaring both sides. We don't want, so when both sides have square root, to remove the square root, if you square both sides, the root will be gone. So squaring both sides, what do we get? We get square root of x minus 2 the whole square. This will become plus 0 into 0 minus of minus 5 is plus 5. 0 plus 5 is 5 square equal to square root of, this will become x minus into minus plus 2 the whole square plus this will become minus 9 the whole square. And we have to put this whole square. That is squaring. We have squaring both sides. Whole square here, whole square here. Now the root and square will go. Once you square a term with the square root, square, and so root of this, the whole square is only this. Right? So we get only x minus 2 the whole square plus 5 square equal to x plus 2 the whole square plus minus 9 the whole square. And just the root will be gone from both. Fine. Now let's Let's expand this. This is a minus b the whole square. That's a square minus 2ab. 2 into x into b plus b square, which is 4, plus 5 square is 25, equal to, again we go here, apply a plus b the whole square here. This is a is x, a square plus 2 into x into 2. 2 into a into b plus b square, which is 2 square, plus 9 minus 9 the whole square is 81. Now let's simplify this. So this becomes x square minus 2 2s are 4x plus 4 plus 25 is 29, equal to, this is x square plus 4x, or 2 into x into 2. This will become 4x. This 2 square will become 4. 4 plus 81, right? This is 4 plus 81 is 85. 4 plus 81 is 85. So now what we have, now we'll bring this to this side. We'll bring this to this side. So you get x square minus 4x. We'll bring all the x to this side. This x square will come here, minus x square. 4 plus 4x will become minus 4x, equal to 85. This 29 goes to the other side, this 29. Right? Now if you see x square we can cancel. This is minus 8x, equal to 85 minus 29 is 56. 85 minus 29 is 56. Right? Now, so our x becomes, I'll write it here. So 8x is minus 8x is 56. So x becomes 56 by minus 8, which is equal to minus 7. So our x is minus 7. So our x is minus 7. So the point P is, the point on the x-axis is, so the point is P of x, x comma 0. X we have found as minus 7. So it becomes minus 7 comma 0. The point is P of minus comma 0, which lays on x-axis, and equidistant from points A of 2 comma minus 5 and B of minus 2 comma 9. So this is the answer. So minus 7 comma 0 is the point on the x-axis which is equidistant from the given 2 points. Fine. So all of you can pause the video and take the notes. Fine. Okay, I'll erase this. We'll go to the 8th problem. So the 8th question is, again it says, find the values of y for which the distance between the point P of 2 comma minus 3 and Q of 10 comma y is 10 units. So there is a point P given, which is 2 comma minus 3, and there is another point Q, and its coordinate is 10 comma y, such that the distance between P and Q, this one, is 10 units. Distance between P and Q is 10, that is given. We have to find the value of y. We will find what is the value of y for which the distance between these two, P and Q, is 10 units. So what is given? Given is PQ equal to 10. 10 units 10. Now what we should find? To find this, we have to find the value of y. Y equal to what? What is this y? What is this y? Now which means what is given? So solution is PQ is given as 10 units. So what is our P? This is P. This is Q. So we'll take this as x1, y1. This is x2, y2. So the distance between PQ is 10 units. So what is PQ? Let's find the distance between P and Q. Distance between P and Q is x2 minus x, square root of x2 minus x1. x2 minus x1 is 10 minus 2. 10 minus 2 the whole square, plus y2. y2 is y minus y1. y1 is minus of minus 3 the whole square. This is our PQ. This is our PQ. We are applying this formula, x2 minus x1 the whole square plus y2 minus y1 the whole square. So x2 minus x1 the whole square plus y2 minus y1 the whole square. That is equal to 10. Now from this we have to find the value of y. Now first thing is we want to avoid the square root. So we'll square both sides. So squaring both sides. Squaring both sides. will get here, if you square, you will get square root of 10 minus 2 is 8 square, plus this will become y plus 3, because y minus of minus is plus 3 the whole square, and this whole square, we are squaring this whole square and 10 square equal to 10 square. We are putting the square on this and square on this. Then what will happen once you square both sides? Then this root and square will be gone. Root and square will be gone, right? So we'll have this will become 8 square plus y plus 3 the whole square equal to 10 square is 100. This whole square root and square will get cancelled. It's not cancelling. Square root of x the whole square will be only this. If you square this, you will get this value without the square root. Right? You can think as cancelling square root and 2, but we are not actually cancelling. They are called as inverse function, which you will study in your higher classes. So, now this is what we have. Let's expand this. 8 square is 64 plus this is a plus b the whole square. This is a square plus 2ab, 2 into y into 3, 2 into a into b plus b square is 3 square equal to 100. Right? Now, so what do we get? We get y square plus 2 3s are 6y. I'm writing these two. Then 64 plus 9. 64 plus 9 is 73. Then this 100 comes this side, it will become minus 100 equal to 0. The y square I have written here. 2 into 3 to 6y. 64 plus 3 square is 9. So 9 plus 64 is 73. Then this 100 comes here to become minus 100. So you will get 0 here. So if you simplify this further, you get this is minus 27 equal to 0. Now again we should factorize this and find the value of y. Factorize this and find the value of y. Now again, what is the factorization rule? When you multiply, you should get 27. And the same two numbers, this is minus, which means if you subtract, you should get this number 6. So what are the two numbers a and b? Right? Hope you all are comfortable. In case if you are not comfortable, please watch my video on factorization. I have put videos on factorization on how to factorize such quadratic equation, or you can even watch my quadratic equation chapter. Fine. So you will get multiply two numbers. Multiplication should be 27. Subtraction should be 6, means 9 and 3, because 9 3s are 27. 9 minus 3 is 6. Now it's a subtraction case. One will be positive, one will be negative. So positive will take this sign. Greater number will take plus, and this will be minus. So this becomes y square minus 9y minus 3y minus 27 equal 0. If I take y common, I get y plus 9. Here minus 3 is common, y plus 9 equal to 0. Again y plus 9 is common. You get y minus 3 equal to 0. So what we finally get is y plus 9 equal to 0, or this y minus 3 equal to 0, which means either y is minus 9 or y is equal to 3. Plus 9 goes this side, it will become minus 9, minus 3 goes that side, it becomes plus 3. So our y is these two. The y can be either this or that. So therefore the value of y is, it can be either of these two. There are two answers. Both are right. And where y can be negative also. Don't ignore the negative values, because it's a point. Right? So this is the answer. Y is minus 9 or 3. You can also verify. If you find the distance between P and Q, suppose if you take P, this is just a verification. See, your problem ends here. Verification, you need not do this, but for your understanding, we can verify and check whether the answer is right. You need not do this verification part in your examination, but if you have time in the rough work, you can try to verify your answer is right. Right? How we'll try to find the distance between P and Q. P becomes what? 2 comma minus 3. Then what is Q? Q is 10 comma y. Y is minus 9. Let's take this first case of minus 9. Then we'll verify this. Right? Now what do we get? Now what is PQ? There's a distance between these two. We should get 10. So what is that? 10 minus 2 the whole square. So 10 minus 2 the whole square. If you take it as x1, y1, x2, y2. So x2 minus x1 the whole square plus y2 minus y1. That is minus 9 minus of minus 3 the whole square. So that gives you square root of 10 square. 10 minus 2 is 8 square plus minus 9 plus 3. This is minus 9 minus 9 minus plus 3. Minus 9 plus 3 is minus 6 the whole square. That gives you square root of 64 plus 36, which is square root of 100, which is 10. So we got our PQ as 10 units, which is matching here. Similarly, if you substitute as y equal to 3, if you take P as 2 comma 3, 2 comma minus 3, P as 2 comma minus 3 and Q as 10 comma not minus 9, we'll take this value 3. Second case. So here the case is y equal to minus 9. What happens here? Y equal to 3. Y equal to minus 9, we get this. We get 10. PQ as 10. Distance between P and Q is 10 units. And if you put y equal to 3 and if you calculate PQ, that is what? Square root of x2. So this is x1, y1, x2, y2. So x2 minus x1. So 10 minus 2 the whole square plus 3 minus of minus 3. 3 minus minus 3. Y2 minus y1 the whole square. That gives you square root of 8 square plus 3 minus 1 minus plus 3. 3 plus 3 is 6. 6 square. So 8 square plus 6 square is 64 plus 36. That makes you square root of 100, which gives you 10. That is your PQ. So in both the cases, you got your PQ as 10 here also. Even when y is minus 9 also, the distance between P and Q is 10. If your y is 3 also, the distance between P and Q is 10. Fine. So you need not do this verification in the exam. It's not required. But just for your understanding, you can see this. You can write in the rough and check, make sure that it is PQ is 10. In the exam, if you have time after completing the paper, then you can make sure that the distance between these two, you can quickly check in the rough work whether you get 10. So that you will know that your answer is right. So this is your final answer. Either y is minus 9 or y is 3. Fine. So all of you can pause the video and take the notes. I'll go to the next question. So ninth question. So ninth question is, if Q of 0, 1 is equidistant from the point P of 5, minus 3 and R of x, 6, find the value of x. Also find the distance QR and PR. Right? So we have a point Q and its coordinate is 0, 1. Is equidistant from P and R. So there are two other points. So suppose this point is P and another point is Q, R. And P coordinate is 5, minus 3. So this is 5, minus 3. And this point is R, which is x, 6. And we have to find the value of x. So the point Q, which is 0, 1, it is equidistant from two other points P and R, where P is coordinate is 5, minus 3 and your R is x, 6. Now we have to find the value of x such that Q is equidistant from both. And also we have to find what is the length of PQ and what is the length of PR. We have to find the length of QR and we have to find the length of PR. We have to find this length QR and PR, these two lengths. What is the distance between these 2 points? That also we should find. And so given, what is given? Given is, they have said Q is equidistant from P and R. So which means our PQ is equal to RQ. PQ is equal to RQ. That is given. And what we have to find? To find this, we should find the value of x. Also we should find what is QR equal to what and PR is equal to what. So once you find x, then we can find QR using distance formula. Again PR we can find using distance formula, which is this is the distance formula. Fine. Now let's try to find the value of x first. Let's try to find the value of x first. So let's write the given information. So solution is PQ is equal to RQ. Right? So we'll take this as x1, y1 and this as x2, y2. And let's try to find the distance between P and Q, these 2 points. Right? So this is x1, y1, x2, y2. So what is the distance? That is square root of 5 minus 0 the whole square. x2 minus x1. So 0 minus 5. x2 is 0. 0 minus 5 the whole square. x2 minus x1 the whole square plus y2 1 minus of minus. y2 minus y1 is minus 3 the whole square, and that is equal to square root of r cube. Again we can take this as x1 y1 and this as x2 y2 and find the distance between these two. That is your r cube. Again x2 minus x1, so 0 minus x the whole square plus 1 minus 6 y2 minus y1, 1 minus 6 the whole square. Fine. Now we don't want this square root. So to remove the square root, we'll square both sides. So squaring both sides. Squaring both sides. We get. So now if you square both sides, it will become square root of 0 minus 5 the whole square is minus 5 the whole square plus this is 1 plus 3. 1 plus 3, this is minus into minus is plus 3. So 1 plus 3 is 4 square and whole square because we are squaring this. That is equal to square root of, this is 0 minus x the whole square. This will become minus x the whole square plus this will become minus 5 the whole square. And this whole square. We are squaring this whole square and this whole square. Now square root and square will be gone because we are squaring a square root, so both will be gone. We'll just have only this minus 5 the whole square is 25 plus 4 square is 16 equal to this is x square plus minus 5 the whole square is 25. So we can bring everything to one side. So we write x square plus 25 equal to 25 plus 16. We can bring all the numbers to one side, or we can take all the numbers to the other side. So x square will become 25 plus 16. This 25 will go other side, will become minus 25. So these two will get cancelled. Your x square will become 16 and x is equal to, don't write it as 4 or root of 16. It is plus or minus root of 16. This is very important point where you make mistakes. You just take only the plus sign and you leave the minus sign. Whenever you have x square equal to 16, your x is equal to plus or minus root of 16, which means your x will have two values. So which means your x will become plus or minus 4. Plus or minus 4, which means your x is either plus 4 or minus 4. Your x is either plus 4 or minus 4. So you have two values and both the values have to be considered. So we'll say therefore x is equal to 4 or minus 4. Right? So that is the value of x. Now we should find QR and PR. So both the answers are right. So x will have two values, either 4 or minus 4. Now we have to check what is QR and PR. What is the length of these two? Now to find the length of this one, we have to consider both the values. Now when first case, when x is equal to 4, what happens? What is QR? What is the point Q? Q is 0, 1. And what is the point R? R is x, 6, and x we are taking it as 4, this value. Then we'll take this value in the next step. So x, 6, x is 4. So it will become 4, 6. When x is 4, your R will become 4, 6. And this point is R. This point is R. Now let's find the distance between QR. That's what we need to find. Right? QR equal to square root of, again you can take this as x1, y1, x2, y2. So we'll apply x2 minus x1 the whole square. So 4 minus 0 the whole square, x2 minus x1 the whole square plus y2 minus y1, which is 6 minus 1 the whole square. So that gives you, if I write here, that is equal to square root of 4 square plus 6 minus 1 is 5 square. That is equal to square root of 4 square is 16 plus 5 square is 25, and this gives you square root of 41. Square root of 41. So that is QR. And what is PR? PR is, we have to find the distance between P and R. That gives you PR. Right? We are supposed to find QR and PR. QR and PR. So PR is P. P is 5, minus 3. And our R is same 4, 6. We are still doing the case when x is equal to 4. Then we will do the similar thing when x is equal to minus 4. We have to still find QR and PR. So now we are finding the PR for the case where x is equal to 4. So PR is distance between these two. So that is square root of. We'll call this as x1, y1, x2, y2. So x2 minus x1. And this is x2. So that is 4 minus 5 the whole square. Then y2 minus y1 plus y2, 6 minus of minus 3 the whole square. Right? x2 minus x1, 4 minus 5 the whole square plus y2 minus y1, 6 minus of minus 3. So double minus is coming. You have to be careful. Here we make mistake. You may just put only one minus and you will miss the minus for either -3 or you will miss the minus for the which is coming in the formula. So this gives you that is equal to square root of this will become -1 the whole square plus this is 6 plus 3. Minus and minus is plus 3, 6 plus 3 is 9 the whole square. So that gives you square root of 1 plus 81 that is equal to square root of 82. That is equal to square root of 82. That is your PR. Now the next case when x is equal to -4. So when x is equal to -4, we have to find the value of again PR and QR. So let's find Q. What is Q? Q point is 0, 1. And what is our R point? R point is x, 6 and x is -4. So you'll get -4, 6. Now what is QR? QR will be square root of, if you take this as x1, y1, x2, y2. So x2 minus x1, which is -4 minus 0 the whole square plus y2 minus y1. 6 minus 1 the whole square. So that is equal to square root of -4 the whole square plus this is 5 the whole square. That is equal to square root of -4 the whole square is 16 plus 5 square is 25 and 16 plus 25 is 41. You will get square root of 41. Now PR. See, these two need not match. Here this QR and this QR need not match, but it is here it is matching. It need not match. When x is 4, you may even get the other value. So PR is, so don't expect your PR also should give them 82 because this is 41, so I am getting 41 here. So this is 82, so I should get 82. No. So your PR is what? What is our point P? Our point P is -5, -3, and our R point is -4, 6. So what is PR? PR. So we'll take this as x1, y1, x2, y2. So that is equal to square root of x2 minus x1 the whole square. So -4 minus 5 the whole square plus y2 minus y1 the whole square. 6 minus of -3 the whole square. Fine. So x2 minus x1 the whole square plus y2 is 6 minus y1 is minus of -3 the whole square. That is equal to, I can write here, square root of this is -4 minus 5 is -9 the whole square plus 6. This is minus into minus is plus 3. 6 plus 3 is 9. So 9 square. That is equal to square root of 81 plus 81. That is equal to square root of 162. And this 162 can be written as 9 root 2. 9 root 2 units. Fine. So we have found our PR, QR, right, in all the cases, right? So our QR is root of 41 here and PR is 9 root 2. In this case, your QR is root of 41 and your PR is root of 82 units. So this is how we'll solve this 9th problem. So all of you can pause the video and take the notes. I'll go to the next problem, which is problem number 10. So problem number 10 is find a relation between x and y such that the point x comma y is equidistant from the point 3, 6 and -3, 4. Whenever we want to find the relation between x and y, which means we need to find an equation which has x and y. We need to get an equation which has x and y, right? So I'm reading the question again. Find the relation between x and y, which means we need to find an equation connecting x and y or involving x and y or having x and y such that the point x comma y is equidistant from the point 3, 6 and -3, 4. That is the question. So 10th question. So what is given is there is a point P of x comma y such that this point is equidistant from two other points. So this point is 3, 6, A of 3, 6, and suppose this is B of -3, 4. Now what should be the relation between x and y such that this P is equidistant from these two? P is equidistant from A and B means AP equal to BP. This length is equal to this length. This length, the distance between A and P is same as the distance between B and P. That is given, and we need to find the relation between x and y. which means we should get an equation having x and y. Right? So given is AP equal to BP, that is given. Now what we should find? Relation between x and y. To find this relation between x and y. So which means we should get an equation that connects x and y. So don't think what is relation between x and y. Relation between x and y means an equation that connects x and y, or that has x and y. Right? So now solution. Solution is given that AP is equal to BP. AP is equal to BP. Right? Now let's find what is AP. AP is the distance between A and P. So we'll call this as x1, y1 and this as x2, y2. Now what is our AP distance between this point and this point? That is defined as square root of x2 minus x1 the whole square, which means x minus 3 the whole square plus y2 minus y1. That is y plus y minus 6 the whole square. That is equal to, so that is the distance between A and P, AP. Fine. The next one is, we have that is equal to BP. BP is distance between these 2 points. I have taken this as x2, y2. This will take it as x1, y1 again. So these 2 points. To find the distance between these 2 points, this is x1, y1. This is x2, y2. Again, apply the formula, distance formula. This is our distance formula. That is square root of x2 minus x1 the whole square, which means x minus of minus 3 the whole square plus y2 minus y1 the whole square, y minus 4 the whole square. Right? y2 minus y. y2 is y, y1 is 4. So now the next step is we will remove the square root. So to remove the square roots, we will square both sides. So squaring both sides. What do we get? We get square root of x minus 3 the whole square plus y minus 6 the whole square equal to square root of, this is x minus and minus is plus 3. It will become x plus 3 the whole square plus y minus 4 the whole square, then whole square. So we are squaring this whole thing square and this whole thing square, so that the square root and square will get cancelled. Right? So we get without the square root. Now we write without the square. So this becomes x minus 3 the whole square plus y minus 6 the whole square equal to x plus 3 the whole square plus y minus 4 the whole square. Right? Now we should apply a plus b and a minus b whole square and expand them. This is a minus b form. So a minus b the whole square is a square minus 2 into a into b plus b square. So here a is x, b is 3. Plus again this is a minus b the whole square. Again a square minus 2 into a into b plus b square equal to this one again a plus b the whole square. So a plus b the whole square is a square plus 2ab plus 2 into x into 3. A square plus 2 into a into b plus b square plus this is again a minus b the whole square is a square. This is which is y square minus 2 into y into 4. Right? Fine. So 2 into y into 4 plus 4 square. That is this one. We are applying a plus b whole square and a minus b whole square. So this becomes x square minus 6x plus 9 plus y square minus 12x plus 36. Right? So this will become 6x. This is 6 into y into 2. 6 2s are 12. Then sorry, not x, y. Y. Right? Then this will become equal to x square plus 2 3s are 6x plus 3 square is 9. Don't put 3 square as 6. I have seen people writing that. Plus y square minus 8y. 4 2s are 8 and then y plus 60. Right? Now let's take everything to one side. Let's take everything to single side. Right? Or you can even cancel here itself. This is x square. If this x square comes here, it will become minus x square. We can even cancel x square here. And y square can be cancelled here. Because when y square comes this side, it will become minus y square. It will get cancelled. So you have minus 6x. Then I'll bring this 6x here. So it will become minus 6. Don't cancel this minus 6x and plus 6x. If they are on the same side, you can cancel. If they are on the opposite side, then they should have same sign. So 6x, this plus 6x comes here, it becomes minus 6x. Right? Then we have y minus 12y Bring this 8y here, it will become plus 8y. Now we have numbers 9 plus 36 is 45. 9 plus 36 is 45. Minus 9 plus 16 is 25. That will come here, it will become minus 25 equal to 0. So we have brought everything to the left hand side. 6x has become come here minus 6x. 8y has come here, it has become plus 8y. Right? And also 39 plus 9 is 36 plus 9 is 45. And this is 9 plus 16 is 25. And that has come this side, become minus 25. So you finally get this is minus 12x. This becomes minus 4y because 12 minus 12 plus 8y is minus 4. Then this becomes plus 20 equal to 0. Right? Now we can cancel throughout by 4. Even with minus 4 we can cancel. If you cancel throughout by 4, suppose, which means we can divide throughout by minus 4. Divide throughout by minus 4 because minus 4 is common. So this will become minus 12x by minus 4. Then minus 4y by minus 4 plus 20 by minus 4 equal to 0 by minus 4. So minus 12 by minus 4 is 3x. Minus 12 by minus 4 is 3. So x minus 4 will become plus 1. These two will get cancelled, you get 1. So it will become plus y. This is minus 5. So 20 by minus 4 is minus 5 equal to 0 by minus 4 is 0. So this is the answer. This is the relationship between x and y. So when they say relation between x and y means you should get an equation involving x and y. So what is the relation? When 3x plus y minus 5 equal to 0, then any point that satisfies this condition, that point will be equidistant from A and B. So you will have many points. You will have many points here. You can have a point P also here, which is equidistant from these two. So there can be many x comma y. These will be equidistant. Again, you can take a point here, equidistant. A point can be here. So if you connect all these points, you will get a line. You get a straight line, and the equation of that straight line is what is 3x plus y. And the equation of this line is 3x plus y minus 5 equal to 0. Which means any point which satisfies this condition, any x and y that satisfies this condition, that point will be equidistant from these two points. So you will have many such points which are equidistant from these two points. If you connect all these points, you will get a line. And that is the equation of the line is what that we have got here. 3x plus y minus 5 equal to 0. This is the equation of this line. Anyway, the relationship they have asked, this is enough. Once you find a equation involving x and y or having x and y, that is the relation between x and y. So your x and y should be in such a way that 3x plus y minus 5 equal to 0. So any x comma y which satisfies this condition will be equidistant. Any point that satisfies this condition will be equidistant from the two given points A and B. Right? So all of you can pause the video and take the notes. I will stop this session here. You can watch my next video for the continuation of this. Thank you for watching.